Welcome back to the Knowledge Academy's YouTube channel. We're here with another exciting video in the journey of learning SQL. Today, we're delving into the world of Relational Database Management Systems, or RDBMS. Get ready for an immersive journey into the heart of data management. To give a picture of what we are learning today, just imagine a digital filing cabinet where every piece of information is meticulously organized and interconnected. That is the magic of RDBMS, a system designed to manage data through relational tables. But wait, there is more. Relational Database Management Systems, or RDBMS, does not just store data, it also allows you to retrieve, update, and manage it effortlessly. It's like having a personal assistant for your data tasks. Now here is where it gets interesting. With the power of SQL, you can communicate with your Relational Database Management Systems, or RDBMS, to perform complex operations in a snap. Ready to dive deeper into the world of RDBMS? Let's begin. When we talk about Relational Database Management System, or RDBMS, we usually misinterpret it as the Database Management System, or DBMS, which is incorrect. So let's first understand the difference between Relational Database Management System and Database Management Systems. When we look for differences, the first and foremost thing that comes to mind is the data model. In the realm of Database Management System, diversity reigns supreme. Picture a DBMS organizational toolbox, which supports various models like hierarchical, network, and relational structures. It is like having a toolbox with options for all the data organizations need. But when it comes to Relational Database Management System, or RDBMS, it is all about the relational model. Picture a strict rulebook where data lives in tables with defined relationships, ensuring consistency and efficiency. So, in RDBMS, the model is based on a set of rules applied to it. The next difference between the two is data integrity. When we investigate Database Management System, or DBMS, it keeps data safe, but it is like a security guard without a badge. It performs basic integrity checks, but it may not enforce strict rules on data relationships. Whereas when we look at Relational Database Management System, or RDBMS, there is always a vigilant watchdog for data integrity. It enforces relational integrity constraints like primary keys and foreign keys, ensuring your data is accurate and reliable. Next difference in line is the query language. In Database Management System, or DBMS, can speak many dialects. It may or may not have a standardized query language. This totally depends on the system. It's like adapting to different languages depending on where you go. Whereas in Relational Database Management System, or RDBMS, it is just the opposite. It speaks the universal language of SQL, with SQL as its standard query language. Communication with databases becomes seamless and efficient. The next difference which we encounter in them is normalization. In the world of Database Management Systems, or DBMS, normalization is optional. It's like tidying up your room without a specific method. It may be organized, but there could be redundancy lurking. Whereas when we look for normalization in Relational Database Management System, or RDBMS, this happens to be the master of organization. Think of it as a well-organized filing system. It strictly adheres to normalization principles, eliminating data redundancy and ensuring efficiency. Now let's look at some of the examples of both DBMS and RDBMS. Database Management System, or DBMS, has its stars like MongoDB, Redis, and Cassandra. Each has its strengths, catering to different data needs. It's like a diverse ensemble cast in the world of databases. On the other hand, Relational Database Management System, or RDBMS, boasts heavy hitters like MySQL, PostgreSQL, Oracle Database, and Microsoft SQL Server. These systems handle massive volumes of data with ease, powering enterprise-level applications. Understanding the differences between RDBMS and DBMS is very crucial, as this is the key to choosing the right system for your data needs. Next, we will learn about components of Relational Database Management Systems, or RDBMS. Let's start with the backbone of any database, the database itself. Think of it as a virtual warehouse where all your data lives, neatly organized and ready for action. This overall container holds all the data and related objects. They act as a repository where data is organized, stored, and managed. Now within this database, we have tables. These are like individual spreadsheets with rows and columns defining specific pieces of information. Each column represents a different attribute, like a name or a date, while each row represents a unique record. Now after table, let's look at schema. Imagine the schema as the blueprint of our database. It outlines the structure of our tables, defines relationships between them, and enforces rules to maintain data integrity. It's like the architect's plan for our digital world. Next, after the schema, is data type. So when it comes to storing data, we need to consider the data types. These specify the kind of information each column can hold, whether it's a number, a string of text, or a date. Choosing the right data type ensures accuracy and efficiency in our database. All the components we discussed were essential, but what about keeping our data in check? Now that's where constraints come in. These are rules and conditions applied to our data to maintain consistency and integrity, whether it's ensuring uniqueness, enforcing relationships, or preventing null values. Constraints keep our database in line. Now after setting the database, when we move to using the data from database, it not just only has one data, but we have tons of it, so to speed up data retrieval, we use indexes. These indexes were discussed in the previous video of Introduction to SQL, but let's have a recap. These indexes act like signposts, pointing us directly to the information we need without having to search through the entire dataset. They're like the index of a book or copy, guiding us to the right page in an instant. Now last but not least, we have queries. These are our tools for interacting with the database, written in the language of SQL. With queries, we can retrieve, manipulate, and manage our data, performing operations like selecting, inserting, updating, and deleting. After getting an overview of the components of RDBMS, let's now take the next step and understand the keys in RDBMS. We have used some keys name while we were discussing the difference between RDBMS and DBMS in the data integrity point. Now we will learn more about those RDBMS keys, which makes it different from DBMS in terms of data integrity. In the world of databases, keys play a pivotal role in establishing relationships between tables and ensuring data integrity. These keys serve as unique identifiers for records within a table, allowing for efficient querying and manipulation of data. Now let us understand several types of keys commonly used in RDBMS. Starting with primary key, as this is the star of the show, which ensures each record has a unique identifier, crucial for data integrity. It is the backbone of a table, ensuring each record is distinct and identifiable. Choosing the right primary key is crucial, considering factors like uniqueness and stability. For example, in a table of employees, the employee ID could serve as the primary key, ensuring no two employees share the same ID. Now moving on to the foreign key, they act as a bridge between tables. Foreign keys establish relationships and maintain referential integrity. It establishes relationships between tables, enforcing referential integrity. Think of it as a connection point between related data across different tables. For instance, in a database with tables for employees and departments, the department ID in the employees table would be a foreign key referencing the primary key in the department's table. Now let's explore candidate keys. These are potential primary keys, each uniquely identifying records but awaiting selection. These are potential contenders for the primary key role. They offer unique identification but await selection based on suitability. For example, in a table of employee, both employee ID and employee PAN number could be candidate keys, each uniquely identifying a student. Now moving on to composite keys, a combination of multiple columns forming a unique identifier, often used when a single attribute isn't sufficient. Sometimes, a single attribute isn't enough to ensure uniqueness. In such cases, a combination of attributes forms a composite key. For instance, in a table of products, a combination of product, ID and batch number could form a composite key. Finally, let's discuss superkeys, a set of attributes that uniquely identifies records broader in scope than primary keys. These are sets of attributes that uniquely identify records. They encompass a broader range of attributes compared to primary keys. An example would be a combination of attributes like name, address, and phone number, forming a super key for customer records. These are the 5 vital keys of RDBMS. These are important and will be used frequently when we will be learning SQL further. Now do you remember we discussed a component normalization? Let's understand it and its techniques a bit, and we will have an example which will make it easier for you to understand this important concept, which is very frequently used, especially when you go on to solve case studies. So, in relational database management systems, normalization is the process of organizing data to minimize redundancy and dependency, ensuring efficient storage and maintenance. Let's consider a real-life analogy to understand normalization in a relational database. Imagine you have a wardrobe filled with various types of clothing items, including shirts, tops, pants, dresses, and accessories. Initially, you might have everything mixed together in one drawer, making it challenging to find specific items quickly. Using the wardrobe analogy lets us further understand the steps of normalization. First step is first normal form, denoted as first NF. In RDBMS, first NF involves organizing data into tables where each column contains atomic values and there are no repeating groups of columns. This eliminates duplicate data and simplifies queries. Let's take up the wardrobe example to understand it. You decide to organize your wardrobe by separating different types of clothing items into distinct drawers or compartments. For example, you might have one drawer for tops, another for pants, and a separate area for frock. This separation ensures that each clothing item is stored separately, like breaking multivalued attributes into separate columns in a database table. Next up is the second normal form, denoted as second NF. The second normal form builds upon first normal form by ensuring that non-key attributes are fully functionally dependent on the primary key. This means breaking down composite keys and moving related data into separate tables to avoid redundancy. Again, let's investigate the wardrobe example. Building upon first NF, you further organize your wardrobe by arranging items based on specific attributes such as color, size, or fabric. For instance, within the tops drawer, you might group tops by color or size to make it easier to find the desired item. This separation reduces redundancy and ensures that each attribute is fully functionally dependent on the primary key, akin to removing partial dependencies in a database. Now the last step is the third normal form, denoted as third NF. Let's first move to the example, then we will understand the technical terms. In the same wardrobe example, the fabric of a tops might determine its care instructions. So you create a separate reference guide or label indicating care instructions independent of the clothing item itself. This separation eliminates dependencies between unrelated attributes and ensures a streamlined organization, like eliminating transitive dependencies in a database. In3NF further refines the structure by removing transitive dependencies. It ensures that each non-key attribute is directly dependent on the primary key, reducing data redundancy and improving data integrity. By organizing your wardrobe in this normalized manner, you can easily locate clothing items, avoid clutter, and maintain an efficient storage space. Similarly, in a relational database, normalization helps maintain data integrity, reduce redundancy, and facilitate efficient querying and maintenance. With these normalization techniques, we can streamline data storage, minimize update anomalies, and improve query performance in our RDBMS. When we learn something new, there is always a curiosity to know in what all place they are in use. So let's look at some of the most popular relational database management systems, or RDBMS, which are in use today. First is MySQL. It is an open source RDBMS known for its reliability, scalability, and ease of use. It's widely used in web development and applications requiring a robust database solution. Next is PostgreSQL. This is another powerful open source RDBMS with advanced features such as support for complex queries, JSON data types, and extensibility. It's often preferred for applications requiring strong data integrity and SQL compliance. Next is Oracle Database. Oracle Database is a commercial RDBMS known for its performance, security, and scalability. It's commonly used in enterprise environments for mission-critical applications and large-scale data processing. Last but not least is the Microsoft SQL Server, SQL Server, developed by Microsoft. It is a popular RDBMS with comprehensive features for data management, business intelligence, and cloud integration. It's widely used in Windows-based environments and offers seamless integration with other Microsoft products. These are just a few examples of the many RDBMS options available today. Each has its own strengths and features, catering to different use cases and preferences. So, to sum up, relational database management systems, or RDBMS, are indispensable tools in modern data management. offering organizations the ability to store, organize, and retrieve data efficiently with the foundational principles of the relational model, normalization techniques, and the power of SQL. RDBMS provides a robust framework for ensuring data integrity and scalability. It serves as the cornerstone of data-driven decision-making, empowering organizations to unlock valuable insights from their data assets. As the digital era progresses, the significance of RDBMS will only continue to grow, shaping the future of data management and analytics. This is all for this video. We'll meet in the next video to learn about the installation and setup of MySQL on Windows, Mac OS, and Ubuntu. This will be the next step in the journey of learning super exciting skill of SQL. If you enjoyed this video, hit the like button and subscribe to our channel for more exciting and informative content. Don't forget to turn on notifications so you never miss an update.